In this video, we consider the problem related to concepts of resistance and resistivity. We have a wire with a resistance of 6 ohm, which is drawn out through a die, and the final length of this line is 3 times its initial length. We need to find the resistance of the longer wire, assuming that the resistivity and density of the material are unchanged. First, I would like to discuss the intuitive solution of this problem. We know that the resistance of the wire can be calculated using this equation, where ρ is resistivity of material, length is length of the wire, and area is cross-sectional area of the wire. When length of the wire increases 3 times, it means that here will appear multiplier 3. We assume that the area of cross-section of wire will decrease 3 times. And for this reason, we need to add here multiplier 1/3. So 3 divided over 1/3 is the multiplier for Ri to get final resistance. So this is equivalent to 9 R initial, and plugging in the value of initial resistance, we get the final answer. This is a short solution, but what we need to verify is that the area indeed decreases 3 times, not less, not more. We will do this right now. So we have 2 wires which have different lengths, and resistance of one of them is given. We denote cross-sectional area of the first wire as AY, and use equation for resistance of the wire, applying it for initial wire. We do the same for the second wire, and just mention that ρ here and ρ here, the resistivity of the material is the same as it is given in the formulation of the problem. Now we can find a ratio, initial and final resistance. So here is this ratio. We plug in here right-hand sides of these equations. We can cancel ρ because it is the same and get more simple results. LF is equal 3Li, so we can replace this with 1/3. And for this ratio, we have the following answer. Now we use the condition that not only resistance but the density of the material is the same for these 2 wires, as is written in formulation of the problem. So we can conclude that the volumes of these wires are equal. We consider the wires as cylinders and find the volumes of these cylinders for initial case and for the final case. So area times length. Now we plug in these values to the main equation and get the following relation between final and initial wires. We can represent this as a proportion. And again, we have here 1/3. Now we mentioned that this ratio and this one is the same, so we can use 1/3 here. And finally, we get that the ratio of initial and final resistances is 1/9. From here, we can obtain that final resistance is 9 times initial one. And using 6 ohm for initial resistance, we get the final answer 54 ohms.